Japan's groundbreaking moon mission, a discovery that could redefine lunar exploration in a historic moment for space exploration. Japan has made a stunning achievement by becoming the fifth country to successfully land a spacecraft on the moon. But what's even more remarkable than this accomplishment is the unexpected twist that followed. Japan's pioneering moon sniper mission, carried out by the highly advanced SLIM lander, has sent back data that has left even NASA scientists in awe. The images and findings from this mission are so surprising, they could potentially change everything we know about the moon, and perhaps even our place in the solar system, forever. Japan's SLIM lander, precision landing technology. For decades, scientists believed they had a fairly solid understanding of the moon's surface, its geology, and its resources. But Japan's SLIM lander, a masterpiece of space technology designed for ultra-precision, has turned those assumptions upside down. This isn't just another space mission, it's a game-changing leap forward in landing technology. Unlike previous lunar landers that could only approximate their landing sites within several kilometers, the SLIM lander is capable of landing with unprecedented accuracy, within just 100 meters of its target. This is a huge breakthrough. The ability to land with such precision opens up new possibilities, allowing us to explore parts of the moon that were previously unreachable or too risky to approach. Launched by JAXA, Japan's space agency, the SLIM lander isn't just proving the concept of precision landing, it's actively exploring the moon's surface, uncovering new data that even NASA, with all its expertise, hadn't anticipated. As NASA prepares for its Artemis missions, which aim to return astronauts to the moon, the discoveries made by SLIM have sparked intense interest, and raised questions about what we may have missed in past missions. The surprising discoveries, what SLIM found on the moon. While the primary goal of SLIM's mission was to demonstrate landing accuracy, it quickly became clear that there was much more to this mission than anyone had anticipated. When SLIM touched down, the data it began sending back shocked scientists. Immediately, its onboard instruments detected unusual rock formations that didn't match anything previously catalogued in lunar geology. This finding has prompted scientists to question whether the moon's geological history is far more complex than previously thought. Some experts believe these strange rock formations could be evidence of volcanic activity that happened much later than expected. Others suggest that SLIM might have uncovered something even more mysterious, perhaps remnants of ancient asteroid impacts that have never been fully studied before. But the surprises didn't end there. SLIM's sensors also detected unexpected signatures deep beneath the moon's surface. Preliminary analysis suggests the presence of a metallic anomaly buried under the regolith, the loose layer of soil on the lunar surface. Could this be evidence of an asteroid impact that deposited metallic remnants on the moon's surface? Or is there something even more extraordinary lying beneath the surface? The possibilities are endless. Could SLIM have discovered water ice on the moon? As if this wasn't enough, SLIM's instruments detected something even more astonishing, possible signs of water ice in an area of the moon that scientists had never considered as a likely location for ice deposits. If this finding is confirmed, it would be a groundbreaking discovery. Water ice is crucial for future lunar exploration and long-term human habitation on the moon. If water is indeed present in places we never thought to check, it could drastically change how NASA and other space agencies plan future missions, including the establishment of lunar bases under the Artemis program. For years, scientists have believed that water on the moon might be limited to certain regions, particularly the permanently shadowed craters at the poles. But if SLIM has uncovered water ice in an unexpected area, it could open up new possibilities for resource extraction and human settlements far from the polar regions. This could significantly alter NASA's future lunar exploration strategy. Why NASA is taking notice, what does it all mean? NASA has studied the moon for decades, meticulously mapping its surface and analyzing its geology. So, how did they miss something as significant as SLIM's discoveries? The answer may lie in the limitations of previous missions. Earlier landers and rovers typically landed in safer, well-mapped regions, areas that were thought to be scientifically safe or devoid of surprises. This breakthrough in landing technology has given scientists their first real opportunity to study an uncharted region of the Moon. The data from SLIM suggests that there may be entire regions of the Moon that were previously overlooked, or, worse, dismissed as unimportant. If SLIM's findings are confirmed, it will force NASA to rethink its assumptions about the Moon's geology and its potential resources. The technology behind the discovery, a new era in lunar exploration. So, how was SLIM able to make these surprising discoveries? The key lies in the sophisticated technology it was equipped with. Unlike previous missions that relied primarily on surface cameras and limited spectrometers, SLIM was outfitted with cutting-edge instruments, high-resolution optical sensors, infrared scanners, and precision altimeters. These tools allowed the lander to map the terrain in unprecedented detail, enabling it to uncover features that were completely invisible to older, less advanced technology. This advanced suite of instruments didn't just help SLIM land accurately, it allowed the lander to peer beneath the lunar surface, revealing hidden features and geological anomalies that could completely alter our understanding of the Moon. One of the most significant questions now is whether SLIM's findings suggest more geological activity on the Moon than we previously thought. Could these strange rock formations be signs of ancient volcanic activity? Or perhaps they're the remnants of an asteroid collision that altered the landscape in ways we hadn't considered. If SLIM's data holds up, it could lead to a complete revision of lunar geological history. Could NASA have missed something critical? NASA has long been the leader in lunar exploration, mapping the Moon, studying its surface, and sending rovers and landers to learn more about its composition. But SLIM's findings suggest there are still major gaps in our understanding. The high precision of SLIM's landing has given scientists the ability to study an entirely new, unexamined region of the Moon, one that may hold secrets we've overlooked for decades. For years, NASA's lunar missions have focused on safe, scientifically well-known areas, avoiding rough or uncharted terrain. But SLIM's mission could open up new, previously unexplored frontiers. If the data from SLIM holds up, it may prompt NASA to rethink its entire approach to future missions and landing sites on the Moon. What's next for NASA? The future of lunar exploration. As scientists digest the implications of SLIM's discoveries, the big question now is, what's next? Should NASA send another mission to verify SLIM's findings? Should the Artemis program reassess its landing sites based on the new data coming from Japan's precision landing system? SLIM's discoveries could have far-reaching consequences for future lunar missions. If the presence of water, ice, metallic anomalies, or unique geological formations is confirmed, NASA may need to reconsider where it places its lunar bases. These findings could also influence the Artemis program's approach to resource extraction on the Moon. Water, metals, and other resources could be more accessible than we initially thought, changing how future colonies are built and sustained. A new era in space exploration, NASA and JAXA's growing partnership, beyond just scientific breakthroughs, SLIM's success may open the door to a stronger collaboration between NASA and JAXA. Japan's achievement in landing with such precision has made SLIM's technology a key asset for future space missions, especially for NASA's Artemis program. By incorporating JAXA's cutting-edge landing systems, NASA could explore parts of the Moon that were previously